So, ladies and gentlemen, when grain availability is getting volatile, quality is sometimes compromised. Ernst Neff will talk about strategies and opportunities to maintain feed quality throughout the feed production process and storage. And he will also elaborate on ways to reduce energy consumption because, like previously mentioned, pretty hot topic these days. So, Ernst, the stage is yours.
Thank you very much. Good morning or good afternoon to all of you around the world, and welcome to the FeedTechnoVision 2022, also from my side. Thanks for the introduction about me, and so we can go directly to my first part of my topic, which is optimizing process technology in times of grain and energy scarcity. Of course, well, I believe all of you agree that with a global feed production of roughly 1 billion tons in 2021, the feed milling industry definitely is an important link in the food chain. Even though growth increasingly moves to Asian, recently also to African countries, the task of our industry will still remain the same. We want to manufacture high-quality feeds and ensure that every animal receives in their daily ration the nutrients and active substance in sufficient quantity and correct quality. So what are the Is it not moving? Wrong. Okay. So what are the challenges and opportunities in case of raw material scarcities? A huge effort must be placed to the raw material procurement, but also to nutritionists and formulators to find new alternative products in good qualities, sufficient amount, reasonable prices, and of course in shortest delivery time. Whatever these raw materials are looking like, in many cases agro-industrial byproducts, variations in product properties like physical, chemical, but also specific characteristics will change in comparison to our standard products and are affecting our manufacturing process. Of course, manufacturing process starts at the intake of raw material and it ends at the dispatch of finished products. But we want to focus on core processes like dosing and weighing, size reduction, mixing, pelleting, and cooling. However, there is one issue most plants around the world facing in common. We need short-term solutions, and we are forced to work with what we got in terms of plant layouts and equipment, and must try to do our best to maintain quality and plant efficiency as good as possible. Means in the first stage, we have to optimize existing processes, possibly raise the awareness to our production and maintenance staff to operate their equipment in a more efficient way. Long-term solutions associated with major investments like plant modifications, new plant, need time to be planned, and this time currently is not available. That's why minor investments with short delivery times, short paybacks, and benefits for the future might be a possibility. Why not? So, looking at, besides the scarcity of raw material, in many regions, they are suffering on bottlenecks of skyrocketing prices in power supply. For this reason, it must be of interest to have at least an idea about specific power consumption in individual process sections. Obviously, conditioning and pelleting together with size reduction are responsible for approximately 75% of the total energy and are those processes with the biggest energy savings potential. There is not much energy to save on all the other sections because a chain conveyor or a bucket elevator, for instance in an intake system, just needs a certain motor size to convey the product from point A to point B. Hence, approximately 90% of the 60% electric energy is used to drive motors and the rest is for accessories. The 40% thermal energy mainly invested into steam generation for the conditioning process. Compressed air will be discussed later on in part 2. So good quality starts with high accuracy in the dosing and weighing section. While scraping together all kinds of suitable raw materials, their varieties in different qualities and properties will increase. These may ask for additional bins, proportioning bins, and possibly a bin reallocation for some raw materials. The question is then, are we having raw material bins, and is their design and the associated dosing element, together with the subsequent size of the batch scale, suitable for the new product? For accuracy reason, the smallest dosed quantity not supposed to be less than 4% of the scale capacity. So dosing suddenly a high-density product from a system-optimized low-density product bin leads usually to unacceptable overweights, at least in the first few batches. In such cases, initial set values for fine dosing and pre-cutoff weights must be redefined for the new product. Grinding is one of the key processes for a successful pelleting process. As shown in the example of barley and corn, different raw materials are different to grind. As a rule of thumb, we can say higher the fiber, fat and moisture content, higher the energy consumption, lower the throughput rates on the grinders, and in the meantime also particle size distribution will change. An idea about grindability of different products will be given by the so-called GKW factor, which is a specific energy factor. So in this case, common optimizing possibilities are frequent screen changes, which are labor-intensive, time-consuming, and limited in flexibility. Much more advisable is the use of VSD drive, variable speed motors, variable speed drives in main motors of hammer mills to optimize particle size with circumferential speeds of the beaters, providing higher flexibility, less downtimes, and energy savings. Overall, an improvement in the grinding efficiency in general. Potential of energy savings by correcting deficiencies in grinding plants. Screens, as shown on the slide screen, purchased quite often in the local market, often not showing the correct configuration. Wrong hole arrangement, too small of open screen areas are resulting in lower efficiency of the plant. 60 degrees in hole arrangements in direction of rotation and 30 to 50% of open screen area are standards nowadays. Well-designed aspiration systems are indispensable in horizontal grinders, but often poorly maintained. Lack of air volume due to jammed filter bags or missing differential pressure gauges. Long exhaust lines ask for higher negative pressures on the fan, hence more energy is required. Beaters are typical wearing parts. The more wear advances, the lower their efficiency. So beaters must never become shorter than original length. For instance, shown in the picture, 5 to approximately 10 millimeter, absolute minimum. At what stage to change the beaters depends very much on energy requirements compared with the spare part costs. All these deficiencies have a direct impact on energy consumption or capacities, heat increment of the product, and finally also to the average particle size distribution of our finished products. Potentials for energy savings associated with moderate investments into the plant layout. Application of roller mills in combination with hammer mills in pre-grinding as well as in post-grinding plants counts today as a state-of-the-art grinding technology. Besides a more uniform particle size distribution, remarkable energy savings up to about 30% can be achieved, depending of course on product properties and required particle size. After the pre-screening section in a post-grinding plant, the product passes to the roller mill, will be ground, and it goes afterwards into second screening sections and fractioning section, and the finally remaining 30 to 40% of the total batch size will then join the second grinder. In case of layer feeds, there are a possibility to bypass the second hammer mill section completely. Furthermore, roller mills provide a more gentle treatment of the product, what generates less heat and accordingly less moisture losses, which is also of importance. Achieving a good homogeneity within shortest time, this is the goal of the mixing process. Providing ingredients in terms of particle size and bulk density are as uniform as possible. But on the other hand, bulk density of the mixture directly relates to the permissible batch size in kilograms. given by the mixer capacity in decimeter cube or liters multiplied by the bulk density in kilos per decimeter cube. Lower the bulk density, smaller the batch size will be. Overfilling mixers not overfilled mixers are not able to provide a good homogeneity. Energy, moisture and other shortages in alternative products might have to be compensated by the addition of liquids into the mixer. This within a given minimum and a given maximum time as shown in the graph, 20 to 30 seconds of minimum time, maximum 60 seconds for a maximum time. After the mixing process, liquid addition, the mixer needs a certain dry mixing time, and this dry mixing time is very much depending on the model of the mixer. As you can see there, it says about 2/3 for certain mixer types. On other ones, it's a longer period. So, and then after dry mixing time, we should be already close to a CV below 5 before we add the liquids. Because liquids are going to stabilize the mixture, and if we add it too early, we won't reach the CV below 5. Then after the liquid addition, we will go for a certain wet mixing time. And after this wet mixing time, the mixer is supposed to be discharged or stopped. This to avoid demixing effects and the waste of energy. In case of frequent starts, the use of soft starters are recommendable. So much to my first part of the presentation. I will see you again in the second part.
So thank you so much, Ernst. Right now at the table, we still have Geke with us, and also Paul Kolen. He is the Livestock Program Manager for Middle East and Africa at Trouw Nutrition. You joined it in 2011, working in various roles such as Product Manager for Celco Feed Additives and Global Program Manager Feed Safety. And right now, actually, you gained practical experience in the industries in Asia, in Latin America, and in Africa. So we're happy that you're here as well. First of all, I have a couple of questions for you, Ernst, and then I will open up the discussion for the rest of the table. Let me start with the person that asks about globally, up to 30% of harvested raw materials are wasted due to poor storage management, somebody says. How can we improve the raw material storage management? What's the...
Okay, storages in certain areas, it's a must, depends on the delivery.
Yes.
There are a number of feed mills without storage silos, they're just day-to-day base. But where you have storage facilities, it is important that the storage facilities are equipped with the right equipment. So especially in Asian countries where the climate is quite hot and humid.
Humid also, yes.
You must have
high humidity.
Yes, you must have aeration systems, ventilation systems for the bins, in order not to take the risk of mold formation and cellular respiration of the raw material and spoiling the raw material. And this is very often not the case. And the other thing is, the best thing is to have it in short as possible time in storage silos.
Yes. Then a couple of other questions. Somebody says, hello, sir. That's you. For which type of animals pellet feed is advisable more? Thanks for your presentation, by the way.
Okay. For which type of animals? Basically, nowadays, pellets are almost used for all kinds of animals, livestock animals, except layer feeds.
All right.
Layer feeds in many regions still in mash feed, and there are different opinions. Some people say never pelletize layer feed,
okay.
and other ones says why don't we pelletize it and crumble it afterwards. So opinions among nutritionists and production guys, it's very different. But the rest of the animals, it's basically all in pellets, at least for now. There are in certain areas, there are trends to go away from pelleted feed again in order to save energy. As you have seen in the presentation, pelleting it's the largest energy consumer.
A huge amount of, what was it?
60%. 60%.
In the whole process. Yes. Any add-on, Paul?
Yeah, maybe. I think it's also considerably where you're allocated. No, so you see still in parts of Africa that still broiler feed is particularly mesh feed, so not pelleted yet. I think the larger part of Asia and for sure Europe and Americas is pelleted feed, and I agree with you. Yeah, the layer feed is more or less the mesh feed. But then with the mesh feed, you have the uncertainty of the quality factor. Huh?
Yes,
it doesn't have the heat treatment. So. So you need to overcome or mitigate the potential risk.
Yes.
In order to safeguard the feed. Yeah.
Yes. A couple of other questions, very specific. So let me choose. Again, somebody asked Mr. Ernest, what do you mean by liquid addition in the mixer? And please, can you explain it a little bit more? The mixing cycle.
Mixing cycle. Okay. All right. So when it comes to liquid addition.
Yes.
Then we are talking, first of all, we are talking about the mixing time.
Okay.
And the mixing time is defined by the mixer, type of the mixer. Let's say 3 minutes.
Okay.
For a conventional mixer, 3 minutes.
Yes.
Mixing, the liquid addition time takes maximum 60 seconds. And the liquid addition time does not count as mixing time in the control system. The control system says, for instance, for a mixer with 3 minutes of mixing time, 2/3 are dry mixing,
yes,
and then we expect that our CV is already close to the 5% line or even below.
CV is in coefficient of variation.
Correct. Yes. And then we add the liquids, and after liquid addition, after this maximum of 1 minute, we are going to continue mixing for a conventional mixer for another minute, to 1/3 of the mixing time, and then we discharge.
Okay.
Quite often, there is not an enable to discharge, and then in many plants, the mixer just keeps going until you get the enable. And during this time, over mixing time, you are going to take the risk of a demixing effect.
Okay.
And the demixing effect could be anything. It could be within the 5%, or it could do waves much bigger. Nobody knows. Has scientifically not been evaluated, and most probably nobody will do it because we shouldn't do it.
Okay. And now a very specific question pops up. I will raise it. Don't know if you. Somebody says we had a case that we add water plus surfactant and no improvement of the final feed moisture. Could you please explain the reasons behind that?
Not improvement in feed moisture. Okay. I guess we had to look a little bit more in details in this case. But maybe Paul could say something.
I'd like to save the question for my pitch, because I give some tools how feed millers can contribute to analyze their own moisture profile in order to analyze if I'm going to add a preservative in combination with water, will it do any effect?
Benefit. Okay. Yeah. Thank you so much. So please. Listen very carefully to the presentation that subsequently Paul will have, and otherwise, please raise again the question, and then we will elaborate on that. Yes. Okay, and then finally, and then I will open up for everybody. What do you recommend, pre or post grinding system?
Nowadays, it's post grinding systems,
and that's also what you recommend.
Yes, it's the main reason. It's investment costs.
Okay.
Pre-grinding systems are much more expensive, space consuming, and cost intensive.
Okay. Of course, the main question right now should be, what impact do you expect in raw materials characteristics in your market? So how can we improve? Other question that is a little bit similar to that is that somebody asked, what should the strategy be? What is the strategy, and what to do to minimize maybe the downtime of the factory, especially when we have to deal with different feed recipes or to accommodate urgent orders from customers? Could you say something briefly about the downtime of the factory?
Downtime of the factory, it's very much related to the way the plant is operated by the operating staff, by the production staff, and by the maintenance crew. I believe.
Yes.
So a well-maintained plant and a well-organized production, the downtimes actually it's limited to a few minutes maybe.
Okay.
But I have shown you, for instance, one example for screen changes. If you have to change the screen on a hammer mill, you have to wait until the hammer mill is stopped from coasting around.
Yes.
takes 20 minutes, open it, clean it, put the new screen in it, easily you're losing a half an hour.
Yes.
And this is maybe something we should look into automation.
Yeah.
For
or
instance,
train to do it quicker.
You cannot do it quicker unless you're going to break it by hand, which is not allowed.
No, let's not do that. What impact do you expect in raw materials characteristics in your market? That's actually the question that I've raised also for the attendees. And also here, of course. Let me just briefly ask this question, Geke, first to you and then Paul. What impact do you expect in raw materials characteristics in your market?
Well, first of all, also to add a little bit on what Ernst was saying, when I look at characteristics of crop, so I always, from a quality perspective, you always think, well, what can I prevent? What can I prevent? And when you have prevention of, for example, hazards like salmonella or then everything becomes easier afterwards. But I know when you are growing crops, when you are harvesting crops, some things you cannot avoid. You cannot, you have birds flying over your crops and you can have salmonella in your crops. So, and that's something, and that's again, like we have to face that as a fact. We cannot just say, okay, we are going to grow without it.
To minimize it
we
completely.
minimize it, yeah, but you minimize it, but you cannot have 100% certainty. So you have to do something in the course of your process to avoid that. And one of the things is, of course, that we then need to preserve and take care when you have the storage that you have no growth. Apart from having short storage, but also looking again at the things that you are going to talk about is preservation. So I think in looking at characteristics, it is very much that we have to be ready to accept that sometimes product coming in doesn't always have the quality that we had used to have. So we need to preserve better, take much care of that, and also do a lot of more testing probably. So normally I'm thinking in quality assurance is preventing, but in this situation we also really have to look very careful at the testing that we do, the quality controls that we do of our raw materials, both on the physical chemical parameters, but also on things like pesticides, salmonella, to make sure that what's not good is kept out of the factory and is not giving us costs in production and then having to reject in the end of the process anyway. So for me, that are the kind of things we really need to have a different way of looking at.
Paul, what is your take on the impacts on raw materials characteristics?
Yes, I believe it's an interesting question, although I would like to combine it with the previous question as well, about the downtime. The downtime. When you have variability in your quality of incoming raw materials, you need to test. You need to be on top of things, and right at the gate, you need to have lined up your quality parameters. And when we preserve, we mainly preserve to avoid recontamination. Hence, when you have downtime in your feed mill, the more likely you will have contamination. Imagine that you will have condensation in the cooler. In the head of the cooler. And for sure, Ernst will talk about that in the next presentation as well. These are all spots or at dead ends of conveyors that can result in salmonella or enterobacteria.
So it should be cleaned.
Should be cleaned. You need to have thorough cleaning of your feed mill. And the shorter your downtime is, the less likely you will have contamination there, because it's always running. These troubles will start when you have shifts of only 8 hours and then have the standstill time for a reasonable time.
All right. If I see some reactions that the attendees are giving right now on the question, what impact do you expect in raw materials characteristics in your market? Some say higher prices. Some say it can affect the quality of feed, palatability. Another person says less homogeneity, less precision feeding, and you can react upon that. And another person says, well, more extreme weather conditions nowadays due to climate change would reduce the quality of raw materials. For instance, more contamination of various mycotoxins. In which one I saw that you were agreeing on some.
I would a little bit connect to what Geke said already. Sampling of raw material is nothing new. We have done it for the last decades. But today, with different raw materials from different spots, from suppliers, we do not know until now.
Yes.
Nothing bad against them, but I think we have to put, or I believe we have to put much more emphasis on sampling of raw materials in the intake pit.
Sampling of raw materials in the
And
intake
then
pit,
analyze
yes.
it.
Because
The
then
sample will be
you know,
analyzed.
you're much more sure about what's going in. Actually.
Maybe in this connection, quite often what I have seen, samples are taken from a truck, somewhere back of a sample while the truck was discharging. So the discharging part was just the end of the truck, what was in the front of the truck. There is no sample taken from
so
there.
So that's bad sampling, actually.
So samples must be taken from everywhere in the truck.
Okay, which is not a minor detail what you're saying right now. Paul, do you agree that so often
totally.
that happens?
Because it is ideal to take a cross-pooled sample along the truck, that from every part.
Yes.
And sometimes when it comes in by boat, you even further need to distinguish your points where you take actually
Yes, there are plants that are doing it.
Yeah.
Sophisticated
But there are also plants that are not doing
it,
if I believe. Yes.
There are also a lot of plants who not at all take a sample. They say, okay, it looks yellow, so it's supposed to be corn, it's okay.
How does it
maybe
smell?
they smell.
Good quality.
And then, obviously when there is...
Well, you're laughing right now, but I mean, since it is happening, what are the risks? Well, could you maybe emphasize it a little bit?
When you have a lot of sand and chaff in corn, for example,
yes.
It's not the corn particle that's going to be molded in a warm and humid environment. It is the sand and the chaff surrounded by the corn that will pick up the molasses first, and then the spot will be enlarged.
Yes.
And so clean, purified raw material is essential.
Yeah. But on top of that, what is also this is very important, but in the end it's a joint effort. So we also have to look at, okay, who are the suppliers? What is the transport looking like? How to be able to look at, to do the right controls, to know what to control in order to verify whether the quality is good. Because you cannot test everything always. So it is really a combined effort together with the people from quality, the people from production, the people from QC, who together can make a very good sampling plan to decide what do we really need to look at in order to make sure we have the right quality in our process.
So what should be, according to you, Geke, the attention if you are sourcing raw materials locally? I mean, what is very key?
Well, what for me is very key when we are sourcing locally. Sometimes it is even more important to go there. So it's not to physically go there and to really see and have a good relationship with your supplier to make sure you get the right materials. So I think
which in the pandemic, of course, was sometimes
difficult. But in the end, when it is really local, then I really invite people to go to the suppliers, to work with them, to have the relationship, because that gives you the best chance that you receive the right quality.
Paul?
Virtually with camera, but it's good to support people and to understand when they source, to stick with the corn example, when they source local corn, that moisture values might variate a lot. So in that essence, it's good to trigger moisture values and to know that when it's over 15 or 16%, that you might potentially have a risk in storing it for a longer period.
Yes.
So then you need to evaluate. Am I ready to add an additional insurance to that to safeguard my raw materials?
Another question popping in right now, because we were talking about the sampling, and one person says, I have one question: how to take sample from one truck sampling system?
Normally, what I know at least is that you at least take 5 points.
5 different points
in each corner.
In the inside, on the outside.
Let's say 1 meter from the edge of the corner.
Yes.
4 points, and then in the middle 1 or 2. And together you will create a pooled sample.
Yes.
And that gives you
a good impression
of and the size of the boat, truck, whatever. When you at least do that, then you have from
more certainty that it is representative for what is in.
Yeah.
Do you agree?
Actually, there is an unwritten law, we can say, where it says how many samples to be taken from a smaller truck and from a bigger truck. From a smaller truck, maybe 4 samples are sufficient. From a huge truck with 40 ton, then you might have to take 8 or even more.
Okay.
The same counts, not all raw materials, it's supplied by trucks, by bulk. In some cases, it's delivered by bags.
Yes.
And then also bags. Let's say in large shipment, every 5th or every 100th bag,
And
But it is still an estimate of the quality of the total batch, because something like a salmonella, or they are not sitting like homogeneously throughout the batch. So it is still, and that's why I keep on insisting on that. You take samples, that's a very good indication, but you also need to look at prevention, looking at the supply performance, etc., and that gives you the total picture.
Okay,
and avoid recontamination in your plant.
Yes.
This is the biggest problem.
That's the biggest problem.